Today we start working with trig identities, and this is a very, very important topic as we head into next year calculus and really any college class. It's very important. But first we need to take a look at the identity sheet that I gave you. And on the right-hand side you see where it says Trigonometric Identities. We first need to understand something about what an identity is. An identity is nothing more than a truth statement. Or we could also think of it as equality. A lot of times people get up into pre-calculus and they forget what that equal sign means. And I just want you to look over on the right-hand side at the trigonometric identities. And one of the most famous ones is this one. Sine squared, they use a t, I'm going to use an x. Sine squared x plus cosine squared x equals 1. If you look on the right-hand side, you see that trig identity listed, and this is one of the most commonly used trig identities. Now, what does this mean? Well, it means that this side is equal to this side. Now, why am I emphasizing that? It means that these two are interchangeable. Anywhere I see a sine squared x plus cosine squared x, I could replace it with a 1. Okay? So this equal sign, when we're working with trig identities, becomes very important because we have to understand that this left side over here, this side, is the same thing as this side. That means I can replace one with the other. Okay? Now, there's something else we need to understand about this identity. If I know that sine squared x plus cosine squared x equals 1, I can also do a little bit of algebra, and I could subtract cosine squared x from both sides, which would make these two go away. And now I have sine squared x equals 1 minus cosine squared x. Guess what? That is also an identity. The fact that sine squared x is the same thing as 1 minus cosine squared x. That also, just like up here, this first form of the identity, okay, where I said that the left and right sides were interchangeable, well, that's the same thing here. These two sides are interchangeable. Any place I see a sine squared x, I could put a 1 minus cosine squared x. All right? Now, I think you see there's one more way I could write this identity. If I have, let me use a different color here. If I have sine squared x plus cosine squared x equals 1, I could also subtract the sine squared from both sides. And so the sine squareds cancel, have cosine squared x equals 1 minus sine squared x. That is another form of the same identity. And just like in the other two forms, the left side and the right side are interchangeable. That means any place that I see a cosine squared x, I could put a 1 minus sine squared x because they are equal. All right? Now, we have learned a bunch of identities already that maybe you had forgotten about. Okay? For example, we learned, and I'm not going to write all of these down. I'm just going to refresh your memory of some of the ones we already know. We learned, for example, that cosecant of x equals 1 over sine x. Well, that is an identity. I could replace any place that I see a cosecant of x, I could replace it with the 1 over sine of x. That's one we already know. We learned that secant of x is 1 over cosine of x. There's another identity that we know. Let me just throw one more up that we have learned. We have learned that tangent of x, and this is a big one, is sine x over cosine x. We learned that one when we were graphing tangent. And so once again, all three of these are what we call a trigonometric identity, which I said is like a truth statement. The left side and the right side are interchangeable. I can replace one side with the other. Okay? Now, where these come in handy is with our ability to simplify expressions. And it's a skill that in calculus especially is very important. So let's get to some examples like you're going to see in homework tonight. First, you will be asked to simplify. They're going to give you an expression and they're going to say simplify it. Well, let's start with an easy one maybe. How about negative secant of theta sine of theta? Well, what we want to do on all these problems is think, okay, what are all of the identities that I could use with these? Well, I know there's really no other way that I can write sine, but there is another way that I can write secant. Let's list an identity. Don't I know that the secant of theta equals 1 over the cosine of theta? Right? That is an identity. That is a truth statement that we have. So I know that anywhere there's a secant, I can replace it with a 1 over cosine. So let's do that up here. Let's replace this secant with a 1 over cosine of theta. That'll be times the sine of theta, and there's a negative out in front of it. Now, look what we have now. We have a simple fraction problem. I can put this sine of theta over 1, and I can multiply across, just like we always do with fractions. And when I do that, I get sine theta over cosine theta. And of course, it's negative. Now, here's the last question. Is there an identity for that expression? Didn't we just talk about this thing right here? That tangent is the same thing as sine over cosine. Let's write, okay, we listed an identity over here. Let's list another one. Here's the first one we used. Let's list another one. The tangent of theta equals the sine of theta over the cosine of theta. There's another identity that we're going to use on this problem. So once again, if it's an identity, then this left side is interchangeable. The left and right sides are interchangeable. Anywhere I see a sine theta over cosine theta, I can replace it with the tangent of theta. So let's come over here in my problem. I have the negative sine of theta over cosine of theta. I know that's the same thing as the negative negative tangent of theta. And that is my final answer. We have simplified this original expression that we started with. Now, a lot of times people ask, what's the point of this? Well, the point is learning a skill to simplify an expression. Okay, just like back earlier in the year, remember when we learned how to simplify the square root of 50? Remember learning how to do that? And we said that that was the square root of 25 times the square root of 2, and that's 5 radical 2. Okay, that was a skill that we learned earlier in the year. We are learning a new skill, which is taking this expression and simplifying it down to this expression. Let's look at another example. The more of these you do, the more comfortable that you will get with them. All right, let's take a look at this one. Sine x cosine squared x minus the sine of x. All right, that's my expression, and we're asked to simplify it. Now, if you look at your identity list, I don't see anything that looks like this yet. So one of the great tricks for simplifying trig expressions is to always look and see, can I factor? Can I factor something out from this expression? If you look carefully, I think you see that there is a sine of x in both of them. Does everybody see that? There's a sine of x in both of them. So let's factor out that sine of x. If I factor out a sine of x, I'm left with cosine squared x minus 1. Okay? Now, we're getting closer to being able to do something here. Let's come back to our first page. Do you remember these three forms of sine squared plus cosine squared equals 1? Here was one form. Here was another form. Here was another form. Do you see one of those that looks a lot like what we're seeing on this problem? Look at number 2. This one right here. I know that sine squared equals 1 minus cosine squared. Let's look at my problem, our problem that we're working with. We just said that one of my identities, okay, let's list an identity that we might use here. We know that sine squared equals 1 minus cosine squared. And if you look right here in parentheses on this problem, we have the same thing as this right here if I take out a negative 1. Do you remember that if I factor out a negative 1, I can change the order? So let's take a negative 1 out of this thing. Let's make it negative 1 times 1 minus cosine squared x. And that's going to be, this negative 1 is going to be times the sine of x still. Okay, all I did was take a negative 1 out of this expression right here. Now look what I can do. I can come over to my truth statement, and I know anytime there is a 1 minus cosine squared, it can be replaced with a sine squared. So let's do that. Let's replace this 1 minus cosine squared with a sine squared x. So now I have sine squared x, I have this negative 1, and I have this sine of x. And we're basically done with this problem. There's not much, the only other thing that I need to do is simplify these two. Now sometimes people get confused about that. If I multiply the sine of x times sine squared of x, that's the same thing as if I did x times x squared. What would x times x squared be? It would be x cubed. Okay? So this is going to be sine cubed x. We still have this -1, so we'll just put a negative in front of it. And that would be my final simplified answer. So what we're doing is we're taking trig identities and we're writing them down and we're using them with problems. Let's take a look at another example. One of the things they're going to ask you to do is match the expression with one of the following. They're going to give you a list of possible answers like this. They're going to say, okay, it could be A, secant of x. It could be B, -1. It could be C, cotangent of x. They're going to give you D, 1. E is negative tangent of x. And F is the sine of x. And they're going to give you an expression like number 1, tangent of x, cosecant of x. So what they're saying is this expression right here is going to be the same as one of these up here, A, B, C, D, E, or F. It's going to simplify to become one of those. So let's come over to the side and let's list, we're working with the tangent of x times the cosecant of x. Let's list some possible identities that we could use here. First, tangent. Isn't the tangent of x the same thing as the sine of x over the cosine of x? That's one identity we know. And then another one that we know is one for cosecant. I know that the cosecant of x is the same thing as 1 over the sine of x. Okay, those are two identities I know about this expression. Now remember what we said. An identity means the left side and the right side are interchangeable. So look right here. I have a tangent of x. That's the same thing as sine x over cosine x. So let's make that replacement. This is the same thing as sine x over the cosine of x. Okay, that is a truth statement. We know that that is true. Times, I know that cosecant is the same thing as 1 over the sine of x. So let's make that replacement. 1 cosecant is the same thing as 1 over the sine of x. Now, we're trying to simplify this, and if you remember what we've learned about fractions, do you see that I can get out the slasher and cancel something? I can slash those. And if I multiply across, remember when we cancel those, I'm left with the 1. When I multiply across, I'm left with 1 over the cosine of x. Now, if you look at my possible answers up here, A, B, C, D, E, or F, and I look at where I'm at right now, do you see a possibility for 1 over cosine of x? If I look up there, do you remember that 1 over cosine is the same thing as the secant of x? That is another trig identity that we know. We know that to be true. So it looks to me like my final answer is going to be A, because 1 over the cosine of x is the same thing as secant. So the final answer in this case is A, secant of x. Okay, doing an excellent job there. Getting closer here to being done. Let's take a look at one more problem. Let's say that I have, we'll call this one number 2, tangent squared theta plus 1 over tangent theta cosecant squared theta. Okay, and we're going to do this like a matching problem again. Okay, if I come back to my original list here, it's going to show up being one of, actually what we're wanting to show in this case, I'm not going to write a whole new matching list. We want to say, is this the same thing as the tangent of theta? If I simplify this big ugly thing right here, is it the same thing as the tangent of theta? Well, let's come over and make an identity list because we've got several things going on here. One identity that we have not written up here yet is on your identity page, and it is this one. 1 plus tangent squared x equals secant squared x. Okay, that's an identity we haven't used yet, but it's on your list. That is a truth statement, so the left and right side are interchangeable. Look what else I've got. I've got a tangent, so I know that the tangent of x equals sine x over cosine of x. I know that's true. And I know that cosecant of x is the same thing as 1 over the sine of x. All right? All of those statements are true, which can help me make some replacements up here. So look, I've got a big one right here at the beginning. 1 plus tangent squared is the same thing as secant squared. So that means I can replace this with secant squared theta. All right? And on the bottom, down here, I know that tangent is the same thing as sine over cosine. It's actually sine theta over cosine theta. And I also know that cosecant, according to what we have down here, is the same thing as 1 over sine. 1 over sine. Now, it is cosecant squared. Okay? So that means this needs to be 1 over sine squared theta, like that. Now, believe it or not, the trigonometry part of this, the trig identity part of it is almost done. The rest of it is fraction work. Okay? So let's take a look at what I have now. I've basically got a bunch of fraction stuff I got to deal with. Well, if you look, I can do some slashing here. I can mark out this sine, and I can mark out one of these, and I'm left with a sine of theta there. Okay? So now I have secant squared theta all over 1 over cosine theta times the sine of theta. Well, guess what? I need to make one more trig replacement. I know that I have another identity I can add here. The secant of theta is 1 over the cosine of theta. All right, that's part of our reciprocal functions that we know. So on top now, I can replace this secant squared theta with 1 over cosine squared theta because of this truth statement that I know right here. So this top is now all over 1 over cosine theta sine theta. And finally, this problem is close to being done. If you remember, when I have a complex fraction, if I'm dividing by a fraction, I'm multiplying by the reciprocal. So that means I'm going to take 1 over cosine squared theta over 1 over cosine sine, and I'm going to multiply this top by the reciprocal of the bottom. Okay, so it's going to be times cosine theta sine theta over 1. And finally, we are about done simplifying this ugly mess. I can do some slashing. This cosine goes away. One of these cosines go away. And the only thing that's left is sine theta over cosine theta, which we know that is the same thing as the tangent of theta. And we have done what we needed to do. We showed that this ugly, ugly mess is really just the same thing as the tangent of theta. And we are going to stop there for today.